and in that one I have given the title as introduction. So the introductory part of coordinate geometry. Introductory part of coordinate geometry, as you all know, which you have already learnt in your lower classes, the space consists of 3 dimensions, but the 2 dimensions means it is a 2-dimensional plane which consists of only length breadth or breadth height or length height, like that. Only 2 dimensions will have. So what the mathematician did, he thought of dividing the plane to locate any point on the plane. He thought of dividing the plane into 4 equal parts with the help of a horizontal line and the vertical line. See, with the help of that horizontal and vertical line, what is the advantage? What is that we can do with that one? See, what is the smallest part of geometry? Everyone says it is a point. It is a point. Smallest part of geometry is a point. Then if you take, a straight line consists of many points. Straight line consists of many points. And if you take a circle, it consists of many points. If you take a parabola, it consists of many points. So whatever the geometrical figure you take, it is made up of points. So what is the smallest part season of coronavirus? You know what is the size of the coronavirus? It is 0.06 microns. 0.06 microns means how much is it? It's a size in centimeters. If you say it's a size in centimeters, it is 6 into 10 power minus 6 centimeters. 6 into 10 power minus 6 centimeters. See the size of that RNA. It is not DNA, it is RNA. See the size of it. So it is very, very smallest part. It is 6 by 10 power 6. The size is the RNA size, which is now making us to tremble the way it is. It is making the world tremble. So the smallest available size to the human eye is a point, but using microscopes and all this, we can find its size. So that is the reason why whatever the mask is used by the doctors or whoever the people here, and see the virus to enter, how safe is the mask? Because the virus is of this size, then the mask, if it is of if it is made up of cheaper cloth, then virus is very much able to enter inside. So keeping that aside, so what the mathematician did, he wants to name the point. So first of all, understand the coordinate geometry. Coordinate geometry is nothing but the plane geometry plus algebra. Understand that? Plane geometry plus algebra. How can we see that? How it is plane geometry plus algebra? How can we say that? See, what the mathematician thought of doing. In plane geometry, generally, we used to use the geometry box. What is that? Geometry box consists of tools like scale, compass, and all this. If you want to draw a line, generally we used to take the scale and we used to draw the line of some particular length. So here, if you see, the point, the point which is it is made up of any geometrical figure is made up of points. That's the reason why mathematician introduced algebra into it. To introduce algebra into it, he named the point first. He named the point as x coordinate and y coordinate. So to locate a particular point on the plane, he divided the plane into 4 equal divisions, which is very much known to you, which is x-axis, y-axis, and the origin, negative side of x-axis, negative side of y-axis. So if you want to locate any point on the plane, then you have to move some x units on x-axis and parallel to y-axis, y units. So this point is located on the plane. Mathematicians use these two, vertical and horizontal lines. Okay, now by naming the point as x comma y, x and y are used, to represent the variables in mathematics. So if you take this xy, what is x and what is y? They belong to any real number. So if you vary x, if you vary y, you will get infinitely many points as ordered pairs. So thereby all the points on the plane are given by a simple rather we can say ordered pair x comma y by the mathematician. So how he thought of it, and by naming the point as xy, he named the equation of the line. He got the equation of the circle. He got the equation of the parabola. He got the equation of the ellipse. What does it mean? Instead of drawing all these geometrical figures, what the mathematician did, he named the point, which is the smallest part of geometry, and then he made the equations of straight line, pair of lines, or circle, parabola, ellipse, hyperbola, whatever. So every geometrical figure is now expressed as an algebraic equation. This is the purpose of naming the point as xy. So that is the reason why what I am saying, coordinate geometry is nothing but plane geometry plus algebra. Why plane geometry plus algebra? In plane geometry, you have the definitions. You have the definitions or any property defined. So those definitions, using those definitions, he converted every definition to the algebraic form. That is nothing but the coordinate geometry. So to start with, it is a very well-known formula to you. Why I am saying that? It is, you have learned this, I think, in your 8th, 9th class or 10th class itself, which is the distance formula. And distance formula, everyone knows, it is root over x2 minus x1 whole square plus y2 minus y1 whole square. That's okay. But what is that? You have to understand. Distance formula in 2D is root over x2 minus x1 whole square plus y2 minus y1 whole square, where is equal to AB, let me say, where A is equal to x1 y1 and B is equal to x2 y2. Okay, now what I'd like to tell you here, in 2D this is the formula, in 3D also the same formula, but only thing is you learn from here itself. You learn this from here itself, only z coordinate extra added, 3-dimensional geometry. In vectors, vector algebra you might have learned, or even if you don't also, no problem. Vectors and 3D, one and the same. Only thing in vectors, you will have the I bar, j bar, k bar as unit vectors, which are defined along x-axis, y-axis and z-axis like this. x, y and z axis mutually perpendicular to each other. So it is also nothing but three-dimensional geometry only. In vectors, how is it represented is important. Let us suppose A is some xi, A is denoted by A bar, or B is denoted by B bar. Then AB bar, that is distance between them, is denoted by modulus of AB bar. Modulus of AB bar is nothing but modulus of B bar minus A bar, which again leads to this formula only. So while learning the distance formula in 2D, you have to make sure that it is very much similar in 3D and as well vectors. And if you see the complex form, generally the students feel the complex numbers chapter as a complex one, but complex numbers are also very much related to geometry only. So how the complex numbers are denoted? AZ1, BZ2. If you want the distance between two complex numbers, Z1, Z2, complex numbers are generally denoted on the complex plane, but this is the Cartesian plane, real axis, x-axis, y-axis also real, but in the complex numbers, you will have complex plane in which you will have this as real axis and this as imaginary axis, of course, but there also it is simply distance is denoted by modulus of Z2 minus Z1. Again it leads to this formula only, root over x2 minus x1 whole square plus y2 minus y1 whole square. So this is what you have to understand with regards to the distance formula. So the distance formula, discussing after this, what we do, we will be understanding the nature of the points on the plane. What I mean to say by that? What I mean to say by that and how they are useful in the objectives. See, the distance formula will be, you can use it to decide the type of the triangle, to decide the type of the quadrilateral, to find out the circumcenter also. How? The circumcenter. Because I have to, if you know circumcenter, then it will be okay. Otherwise, I'll be taking circumcenter class separately. Okay. So, what is that you have to understand? Here, the triangle. Let me tell you, the triangle is taken with the 3 points A, B, C, and in this one you will have the length of AB, length of BC, length of AC are equal. Then we say that it has an equilateral triangle. If they are unequal, we call it a scalene triangle. If two sides are equal, we call it as an isosceles triangle. If two sides are equal and one angle is a right angle, then we call it as a right angle isosceles triangle. What is the condition for right angle triangle? Everyone knows it is the Pythagorean theorem, which is in fact the Brahmagupta's formula, which they have taken from us only. So this is the square on the hypotenuse is equal to sum of the squares of the other two sides. If it satisfies that we call as a right angle triangle. So like that, you can decide the type of the triangle using the distance formula, and then I'll show you anyway. We will be working out some problems also, and in those problems we'll be understanding that. So if you take a quadrilateral, in a quadrilateral, if opposite sides are, if you get opposite sides are parallel, then we call it as a parallelogram. But if the angle between them is 90 degrees, you know that it is a rectangle. If all the sides are equal, and the angle between them is other than 90, then it is said to be rhombus. If the angle between them is 90 degrees and all the sides are equal, then we say that it has a square. And here, in case of a triangle, generally what is that point we miss in the objectives is that for a right angle triangle, you know AB square plus BC square is equal to AC square. This gives you a right angle triangle. Okay, now if AB square plus BC square is less than AC square, you know, if it is less than AC square, you know, then it is an obtuse angle triangle. If it is AB square plus BC square is greater than AC square, then it is an acute angular triangle. These points generally we don't find in all the books. So, sum of the squares of any two sides of a triangle is less than the square of the third side, then it is said to be obtuse angle triangle. That means need not be this only. Sum of the squares of any two sides of a triangle must be less than the square of the third side. Then that will form an obtuse angle triangle. Okay. So the distance, as far as the distance is concerned, we will have some a black pen. I'm using black pen only. This is black only. Let me check because the lighting and all these are not good. I'll try to improve it. Good afternoon, Srihari. Arun, good afternoon. And then let us say this on the PDF, and we will have some problems solved based on this. You may be thinking that the distance formula is very simple and what is that to be discussed on the distance formula. No, it's not like that. You have many other concepts are depending on this distance formula. So how they are applied, let us see now in this one. So here Samega Oksari, the clarity of the whiteboard, I think you are talking about that black pen only. I'll try to improve it, but today it is that only. Just adjust with that. Now, what I'm saying here in this one, whatever the explanation I gave you is very much given here. This is the quadrants of any plane is divided into 4 equal parts, which are known to be quadrants. Everyone knows that. And the point also I have explained you how it is given. And one more thing you have to remember here is that whenever a point is on the plane, it is at a distance of very important point, that is, it is at a distance of y units from x-axis. It is at a distance of x units from y-axis. This everyone can understand that. So what I mean to say here, if you take any point xy, the point is at a distance of y units from x-axis and x units from y-axis. For example, if I take this, see, this is, let me take this only, here only I will explain. That is, if you take any point here, for example, I am taking a point here, minus 2 minus 3. See, if I take this point here, what is its distance from x-axis? Nothing but y. What is its distance from y-axis? Nothing but x, that is 2. Because it is a distance, we have to take only the positive quantity of it. So you have to understand that if you take a point A comma B, let me say, the point AB is at a distance of B units from x-axis and A units from y-axis. So further, if you want to understand still more about this, I'll explain you like this. See, we will take further the concept of straight line. See, what I do, if you take the concept of straight line, how that is, this concept is used in straight line, let us understand that. See, if you take a set of points, whose y coordinates are same, I repeat, if you take set of points whose y coordinates are same, then the line joining those set of points, how that will be, let us see. See, these are the axis, x-axis, y-axis. Now, let me take a point here, 1, 2. Let me take another point here, 3, 2. Let me take a point here, minus 1, 2. Let me take a point here, minus 3, 2. What is the commonality in all these points? In all these points, you can see that y coordinate is same. Just see that, please. Y coordinate is same. So, when y coordinate is same, what happens now? The height is same for all these points. So, the line joining these points will be parallel to x-axis. And further in straight line, we will be learning its equation as y is equal to 2 simply. Simply we say the equation of the line as y is equal to 2. Now similarly, if you take another set of points whose x coordinates are same. Let me try with the red pen. Other color. See, this is, let me say, this is a point which is 1, minus 3. And this is 1, minus 7. And let me say this is something like 1, 10. What is the commonality of all these points, please? This is 1, this is 1, this is 1, and if you see the distance of all these points from y-axis, it will be same. That means when the distance is same, the line joining all this, is parallel to y-axis. And hence we simply say that since all the x coordinates are same, its equation as x is equal to 1, understand? Its equation as x is equal to 1. So, what is that you have to understand? If you take a point line passing through AB. What is the equation of vertical line passing through AB? You may be getting the question like this, and you will have a part of the question may be consisting of this concept. So when the line is passing through AB and parallel to x-axis, simply we call it as horizontal line. Horizontal line is y is equal to b, and the vertical line is x is equal to a. Simple. So what is the concept we have learned here? The equation of the line passing through a point AB, which is horizontal or which is parallel to x-axis, is nothing but y is equal to b. And the equation of the line which is passing through the point AB and vertical or parallel to y-axis is nothing but x is equal to. So this is what we can understand with regards to the Cartesian coordinate system, which is also useful in solving the questions. Okay, so now let us go through this. So now we will have this is what I explained you. Now let us understand this. And axis of x, axis of y. On x-axis, it is very simple. Everyone knows y coordinate is 0. That is, y is 0. Y is equal to 0 is its equation. And x is equal to 0 is its equation. Similar to this only. So, equation of x-axis is y is equal to 0. And equation of y-axis is x is equal to 0, and all this you have learned in your lower classes itself. Oblique axis, if both axes are not perpendicular, then they are called as oblique axis. If both axes are not perpendicular, then they are called as oblique axis. In some cases you may be getting this oblique axis means if you get that word you must know the meaning of it. Okay, so that's what is given. The y coordinate of every point on x-axis is 0. The x coordinate of every point on y-axis is 0. Now polar coordinates, in fact, the polar coordinates concept, we don't have directly in any syllabus, IIT JEE syllabus or any engineering entrance examination, don't have polar coordinates. But you'll have the same concept in the complex numbers. You'll have the same concept in the complex numbers, and you will be getting the terms, the horizontal component and vertical component in physics. In physics, you'll be getting horizontal component and vertical component. So here, let me explain you here itself. That is, P of r comma theta is the notation of the point used in the polar coordinates, where theta is the angle made by OP with x-axis in the positive direction, and r is the distance. So if you find out x coordinate, x is nothing but r cos theta, which is further you will be getting this as the horizontal component in physics. Horizontal component in physics. This is the horizontal component, and this is the vertical component, and this is of course the distance formula. To join these two, if you divide this, tan theta becomes y by x and theta is equal to tan inverse y by x. This is the polar coordinates. So the distance form, what you have to understand in the polar form, the distance formula in the polar form. But before that, you remember this, horizontal component is r cos theta, vertical component is r sin theta, and as you know in trigonometry, cos theta is adjacent side by hypotenuse, and sin theta is opposite side by hypotenuse. From that only it is derived. So theta is equal to tan inverse y x. Now here let us see the distance form. The polar form of distance formula. Polar form of distance formula. This is a distance formula, as you know. it is derived like this, very simple. This is x1 y1, this is x1 y1, and r is x2 y2. From this one we will have the distance formula. Simply it can be derived using the difference. What is let me write that. This is x1 y1 and this is x2 y2. If you take these points, this PQ distance we need, and you must also understand what is PR is nothing but x2 minus x1. What is QR is nothing but y2 minus 1. And applying the Pythagoras theorem, you will have square of the hypotenuse is equal to sum of the squares of the other two sides, which gives you this formula. Why I'm discussing this here? Because you will have, when 2 points are given like this. Further, this origin, this is x1 y1, this is x2 y2. If you want this horizontal distance is nothing but x2 minus x1. Similarly, vertical distance is nothing but y2 minus 1. You may be getting in solving the problems. That is why I discussed that. Okay, now let us move on to some problems here. Further, let us check it out. As the cosine rule. This is nothing but the cosine rule, please. Cosine rule you will get in properties of triangles. Cosine rule you will get it as in the properties of triangle. The same is given here in the polar form, r1 square plus r2 square minus 2r1 r2 cos of theta 1 minus theta 2. In the application part, what I mean to say, what I mean to say by application part here, if you have a triangle, for example, further, you will be getting the distance between the length of the third side. I'll explain. Just a moment. How to make use of this? See here. You have a triangle in which two sides are given. This side is, let me say this triangle is ABC. Now this side we represent with small a. If you need small a, in this case, this is C. this is capital C, this is B. Then if you want A, that is two sides and the angle between them is given. Remember, two sides and the angle between them is given. Then in that case, how to find the third side? Third side, A square is equal to sum of the squares of the two sides minus 2bc cos theta. This is the formula which we use in properties of triangles. The same is given in the polar coordinates form. Let us see how it is given. It is nothing but R1, please. It is nothing but R2. So he used it. R1 square plus R2 square minus 2 R1 R2. This is theta 1 minus theta 2 he used. Theta 1 minus theta 2 means two sides are taken there. This is cos theta. So if we take the square root of it, then this is the polar form. See, straight away this polar form is not there in mathematics, but you may be getting this in the other subjects. That is why I explained to you. See, here, after learning the polar form, let us now see the applications of it. That is what I mean to say by application, that is problems, simply problems. Let us see the problems here. If the point xy be equidistant from the point a plus b, b minus a minus b, a plus b, then whatever the options are given there, we have to say that it is nothing but the locus. Locus I did not discuss so far because I said it is introduction. Two-dimensional geometry introduction. What I mean to say by introduction, in the introduction, you will have a Cartesian coordinate system. Number 2, the locus. Number 3, the change of axis. These 3 comes under the introduction. If you are thorough in these 3, further you will not face any problem. So, that question is indirectly given. It is given as a condition. So 2 points are given, 2 points that are equidistant. If the point xy be equidistant from the points a plus b, b minus a, and a minus b, a plus b, then what is the condition? See, if you draw, the problem is simple. See what he did, let us see, because it's a worked out example, let us understand this. Simply, it is given to be what? Point is taken as xy and the given points are taken as a and b. And it is given that PA is equal to PB. Squaring on both sides, PA square is equal to PB square. This is P, this is A, PA square written. This is P, this is B, PB square written, and it is simplified and you have got the equation Bx minus Ay is equal to 0. You got the equation, but the combination of the plane geometry and algebra. Why algebra? When the point is given in terms of xy, every geometrical figure will be expressed in terms of xy only. That is nothing but algebra. Here also it is expressed as algebraic form. Just see this, Bx minus Ay equal to 0. How do we understand this geometrically? How do we understand this geometrically? See, let me take another example. I will choose such points that are equidistant from the coordinate axis. What I mean to say by that? I need otherwise such a point which is equidistant from 2 points. Otherwise, let us see. This is, let me take 2 points here. Let me take 2 points. One is x1, y1. Other one is x2, y2. Then, if I take a point which is equidistant from the first point and second point. This is taken to be P there in the previous problem. This is A, this is B. What is that? PA is equal to PB. Okay. Do you think that only one such P exists? No. You will have many P's like that. You will have one more P here. You will have some more. You will have midpoint of AB also, which is equidistant. Midpoint. Equidistant from A and B. Similarly, you can take one more point here, one more point here, like this. If you collect all such points, this forms a line which is the perpendicular bisector of the line segment AB. So what is your learning here? What is your learning here? You are given 2 points. You are given 2 points. And these 2 points are equidistant from a point. From a point. From another point. From one more point. From one more point. Like this, if you collect all such points, that line will be perpendicular to this line segment and it is a perpendicular bisector. So the definition of perpendicular bisector, now which you have to learn, because perpendicular bisector, you will have the same in circumcenter also. For the circumcenter is the point of concurrence of perpendicular bisectors. So what is a perpendicular bisector now? It is the line which is perpendicular to the side, and bisecting the side. So perpendicular, if you choose any point on the perpendicular bisector, it is always equidistant. It is always equidistant from the 2 given points. That's about the perpendicular bisector. So why we are discussing that? Because whatever the condition you have got there is nothing but the equation of the line. That's what I mean to say. Whatever the condition you have got here, just see, what is the condition you have got? Bx minus ay is equal to 0. This Bx minus ay is equal to 0 is nothing but the equation of the perpendicular bisector. So which you will be getting further in locus. See, next. Here, next problem, if the Cartesian coordinates of any point are root 3, 1, then its polar coordinates are. Polar coordinates, we have seen previously, r cos theta is nothing but x. R cos theta is equal to root 3 and r sin theta is equal to 1. Squaring and adding, you will get r value as 2 and theta is tan inverse y by x. 1 by root 3, pi by 6. Polar coordinates are 2, pi by 6. You will get the same in the complex numbers also. In the complex numbers, we call it as polar form. Polar form of the complex number. Polar form or mod amplitude form. Modulus amplitude form in the complex numbers. So you will get the same there. Now properties of triangle, just now I discussed. If in any triangle ABC, AB plus BC is greater than AC, in any triangle, the triangular inequality. The triangular inequality is this. What is the triangular inequality, please? Sum of any 2 sides must be greater than the third side. Sum of any 2 sides must be greater than the third side. The difference of any 2 sides must be less than the third side. Triangular inequality. Sum of any 2 sides of a triangle must be greater than the third side, and the difference of any 2 sides of a triangle must be less than the third side. This is triangular inequality. Triangular inequality. So, equilateral triangle, I need not have to tell you that this is all the sides are equal, and the right angle triangle, the Pythagoras theorem is used here, and even extra thing what I taught you is the obtuse angle triangle and acute angle triangle. What is the condition for obtuse angle triangle, please? For the obtuse angle triangle, this is for obtuse angle triangle, the sum of the squares of any two sides must be less than the square of the third side. Then it is said to be obtuse angle triangle. This is an extra condition you have to remember. Generally, it is missing. And properties of quadrilaterals. Properties of quadrilaterals. Number one is the parallelogram. To prove the parallelogram, the opposite sides must be equal. The opposite sides must be equal, please. Opposite sides must be equal, and whether it is a parallelogram, rectangle, rhombus, or square, whatever. For all of them, the diagonals bisect each other. The diagonals bisect each other. That is the midpoint of. One diagonal is equal to the midpoint of the second diagonal. So in all, the common property for all the four quadrilaterals is that the diagonals bisect each other. And of course, in a parallelogram, the angle between the diagonals is not 90. In a rectangle, the angle between the diagonals is not also 90, but the angle between them is 90 degrees. This angle between any two sides is 90 degrees. Okay, so here for a rhombus, all the sides are equal, please. All the sides are equal for a rhombus, and the angle between them is 90 degrees. And angle between the diagonals is 90 degrees. For a square, you will have all the properties of the remaining. What I mean to say, the opposite sides are parallel, which becomes a parallelogram, and the angle between the sides is 90 degrees, which becomes a rectangle, and all the sides are equal for a rhombus also. And here the extra thing is the angle between the sides is 90 and the diagonals are at right angles and all the sides are equal for a square. So for a square you will have more number of conditions. Okay. Now see here, this question in fact, just can you try this question please? Can you try this question? This is ABC is an isosceles triangle, the coordinates of B. If the coordinates of B is 1, 3 and C is minus 2, 7, the coordinates of vertex A can be, this is the question. These are the options. Okay. Now, in fact, to work out this problem properly in a method, we need the knowledge of straight lines. Because in an isosceles triangle, opposite sides are equal, and hence the angles opposite to them are also equal. Then we take the slope of the third one as m, and we proceed like that to get the third vertex. But in this case, you have to follow the distance, because it is because we are now discussing about only distance here. Isosceles triangle, two sides are equal. So how he did it? Let us check it out. They are using the distance formula only. The third vertex be xy, and A is xy, B and C are given. So AB square is equal to AC square. Now by simplifying that, you got this line equation. What is our line equation? The third vertex must lie on this one. So if you verify this, the only this point 5 by 6 comma 6 satisfies. Just check it out. 6 into 5 by 6, 5 minus 8 into 6, 5 minus 48 minus 43 plus 43, 0. This satisfies, and hence that is the answer. And of course this also satisfies, but it is a midpoint. Of the side. Then how do we say that? So for that one, we need extra concepts of straight lines. In straight line, we will have the exact explanation for this. But for the using the distance formula, it is like this only. Now the extremities of the diagonal of a parallelogram are the points 3, minus 4, minus 6, and the third vertex is minus 2, 1, then fourth vertex is the extremities of the diagonal of a parallelogram. Here I have to give you the midpoint formula, which is not related to distance. Next concept is section formula, which is very well known to you, and the midpoint formula also is known to you, which is x1 plus x2 by 2, y1 plus y2 by 2. Because the problem has come, let me tell you the short form of doing this. Let me tell you the short form of doing this. For all of them, for all the four quadrilaterals, what I mean to say by four quadrilaterals: square, rectangle, parallelogram, rhombus. What is that commonly we use to find out the fourth one? See, if you take a parallelogram, A, B, C, D. If you take a parallelogram A, B, C, D, then in a parallelogram, the diagonals bisect each other. That is, midpoint of AC is equal to midpoint of BD. What is the formula for midpoint of AC? We now follow the vector forms. What does it mean by vector form? A plus C by 2. Simple. We call it as simply A plus C by 2 and B plus D by 2. x1 plus x2 by 2, y1 plus y2 by 2 is the formula. Okay. So we take it in this form, then thereby, if you want the fourth vertex D is nothing but A plus C minus B, please. A plus C minus B. That is, add the extremities of the diagonal and subtract the third vertex. Add the extremities of the diagonal and subtract the third vertex. A plus C minus B. Let us see. Now, after learning this, what is the formula for the fourth vertex? A plus C minus B. Let us see directly that question now. In this question, instead of going through the entire method, simply do it like this. Simply do it like this. What is the extremities of the diagonal of the parallelogram? 3 minus 4 minus 6 5. Add 3 and 6. 3 and minus 6. What is 3 minus 6? Minus 3. Minus 3 minus of minus 2. So, what is that you have to understand? Minus 3, 3, minus 6, minus of minus 2, comma, minus 4, plus 5, minus 1. Just check it out. What is the answer now? Minus 3 plus 2, minus 1, and it is 0. So minus 1 comma 0 is the answer. Minus 1 comma 0 is the answer. So simply make use of that short form. Have the better understanding first how it is derived. How it is derived, the shortcut, how it is derived, just have the better understanding. See, so to get the fourth vertex, A plus C minus B is the formula. Okay. Now, next, if the vertices A and D of a square ABCD lie on the positive side of x and y axis respectively, the vertex C is the point 12, 7, the coordinates of B are. See here, this is not straight away related to distance formula. We'll be discussing that after learning the next concepts. Okay. Now, the example 6, a triangle with vertices 4, 0, -1, -1, 3, 5 is. See, what is the right side? This is A, this is B, this is C. Find out AB square, BC square, AC square. The length of the sides here, you got it to be two sides equal, and the third side is this. So, two sides equal, and the sum of the squares of the two sides is equal to the square of the third side, and hence it is a right angle isosceles triangle, which is very simple. Very simple question. Very simple question. But now, what I'd like to discuss here. See, you may be thinking, so this distance formula only we have discussed. Is there any related problems that are given in the previous paths? Yes, there are. Yes, there are. I have taken some questions which are given in the previous paths. Let me show you that. Let me show you that. See this question, please. Please go to that. If in a parallelogram ABDC, the coordinates AB and C are respectively 1, 2, 3, 4 and 2, 5. Then the equation of the diagonal AD is of course, equation of the diagonal AD, we are not now worried about the equation of AD. Is there any verification method for this one? Using the property, using this property? Yes, there is. You can try it. Anyone, can you answer please for that one? It is given in the recent JEE main examination, that is the January session of 2019. In the January session of 2019. Can you try it please? If you work out, please let me know the answer option. Because it is related to straight line, how it can be seen is asking for the equation of the other diagonal in a parallelogram or rectangle or rhombus or square. The diagonals bisect each other. Obviously, what happens? The midpoint of AC is equal to midpoint of BD. So find out the midpoint of one diagonal there and substitute in the options. Substitute in the options. If double answers are created, then you have to go for the concept of straight line only. Let us check whether only one answer is there or two answers. Arun? Are you there, Arun? Respond please. You can try it, Arun. You can try it. Can you tell me the option? Just what you do now, just find out the midpoint of one diagonal, find out the midpoint of one diagonal and substitute in the options. Which option is satisfied? Just check. That's it. Just check. It is given to be ABDC. ABDC is the parallelogram given. Now, we need the equation of AD here. And BCE, what are the coordinates given? A is 1, 2. And B is 3, 4. And C is 2, 5. It's a very simple question because if you find out the midpoint of this, it is 5 by 2 comma 9 by 2. Not only that, if you want, you will have unique answer now because A and midpoint both must satisfy the equation. 1, 2 if you substitute now, first one not satisfied. Second one 3 minus 10 satisfied. And 5 by 2, 3 into 5 by 2, 15 by 2 minus 45 by 2. That is 30 by 2. Check the answer please. 1, 2. Got the answer? So I'll zoom it, just wait. Is it okay now, Arun? So you can see that 1, 2 is satisfying all these three options. Just check. This is 3 minus 10 plus 7 satisfied, and this is 5 minus 6 plus 1 satisfied, and this is 5 plus 6 minus 11 satisfied. So answer must be among BCD only. Now just check whether 5 by 2, 9 by 2 is satisfying which equation. Just check. 5 by 2, let us write it here in the second option. If we write it in the second option, B I am talking about, B. Three into 5 by 2 minus 5 into 9 by 2 plus how much is it? 15 by 2 minus 45 by 2. That is not satisfying. Minus 15 plus 7 not satisfying. So B is not the answer. Similarly, check for C. C, please. Five into 5 by 2 minus 3 into 9 by 2 plus 1. 25 minus 27 minus 2 by 2 plus 1. See. So which is the answer? C is the answer. C answer. So this we did using verification. This we did using verification. Okay. Now similarly, let us go to the other question. The shortest distance between the points, I'll zoom it. This is also latest question. The shortest distance between the point 3 by 2 comma 0 and the curve y is equal to root x. Now this one. The shortest distance with the point 3 by 2 comma 0 on the curve y is equal to root x greater than 0 is. See, if you take, this is also a good question which depends on the shortest distance. Shortest distance means you have to take that expression and you have to make it short. That is the least. How to? Just see this. The curve is given to be y is equal to root x. The curve is given to be y is equal to root x. Just see this carefully. What I'm taking, I'll take a point now on the curve, on this curve. Yeah, let me say, as x square. If I take x as x square, then y becomes x. Or we must say mod x in fact. If you are confused with this one, then what I do, I'll take like this. I'll take it as a point A as A square comma A. Point A is A square comma A, please. Let me say the given point as P, which is 3 by 2 comma 0. Now you have to make AP distance the shortest one. You have to make the distance AP the shortest. Can you tell me AP, what is AP please? AP is nothing but A square minus 3 by 2 whole square plus A square minus 0. This is nothing but AP square. So what is that you get here? A power 4 minus 3A square plus 9 by 4 plus A. Then what is that you get? A power 4 minus 2A square plus 9. I hope you understand what I am doing there. Okay. 9 by 4. Now this part is to be minimized. How to do that? Just see this. This is now square root of I'll do one thing because you are saying that it is not visible. I'll come onto the whiteboard. Yes. Just wait. I'll explain on the board. I'll explain on the board. Yes, what is the point given? 3 by 2 comma 0. What is the curve given? Y is equal to root x. Okay. Now I'll explain on the board. I'll write the big letters for the better visibility. Just say this. What is a curve given? Y is equal to root x. What is a point given? It is 3 by 2 comma 0. Y is equal to root x means it is nothing but y square equal to x. Further you will be learning it as a parabola. As a point on the parabola. Which point on the parabola is at the least distance? That is the question. So when I choose this point as some a square, then y becomes a. Are you with me? Of course, you must write it as perfectly as mod a because it comes out of the root. But I am not taking modulus there. I am taking only positive part of it. So our point here is a comma a square. Let me say this as P, let me say this as A. Just reply, Arun, whether the board is clear or not. Do you able to see that or not? Just reply. Arun. Good. That's good. Now see here. Now I am writing AP square. What is AP square? The distance between the 2 points squared, which is nothing but. The point is reversed here. The point is a square comma e. I have taken the point as a square comma e. Okay, now tell me what is AP square? A square minus 3 by 2 whole square plus a minus 0 whole square. That I need not have to explain you x2 minus x1 whole square plus y2 minus y1 whole square. That's what I wrote. Now after simplifying this, a power 4 minus 3a square plus 9 by 4 plus x square. It is nothing but a power 4 minus 2a square plus 9. What is it you have to understand here? A is a variable here and you have to minimize it. That means this distance is to be minimized. The distance is to be minimized. So what is that I am trying to do? I want to express it as a perfect square. a square minus 1 whole square. Just to see this carefully. Plus 9 by 4 minus 1. I hope you understand. I made it a perfect square. One added here, one subtracted there to make it a perfect square. Then what is it again? A square minus 1 whole square plus 5 by 4, please. Plus 5 by 4. Okay? Now, AP. AP is equal to square root of a square minus 1 whole square plus 5 by 4. Correct now? Do you imagine now when it becomes minimum or least or shortest? Some positive quantity is always added to 5 by 4. Some positive quantity is always added to 5 by 4. So, this value is always greater than or equal to root 5 by 4. That value is always greater than or equal to root 5 by 4 because some positive quantity is always added under the root to 5 by 4. So whatever the resultant you get, it should be either equal to 5 by 4 or it should be greater than 5 by 4. So what should be your answer now? I hope you understand that. What should be your answer now for this one? Can you type the answer in the chat box? What should be the answer? Arun, answer please. Should I show you the board now? The board is shown. Now, tell me the answer. The least value. It is root 5 by 2, no? Root 5 by 2. Yeah, you're right. You said D, no? D is the correct answer. D is the correct answer. Just see the approach here. See the approach. He asked for the minimum distance. The problem is related to distance only. But of course, the algebra is added here. How algebra is added? The point is lying on the curve y is equal to root x. And hence, we have taken the point as a square comma a. How can we take that? If you substitute a square here, this becomes a, y is a. So this point lies on a. So our variable is a. For what value of a, the point on the parabola is nearest to the given point. If you draw this now, if you draw this, how it will be? The curve is y is equal to root x. The curve is y is equal to root x. It is like this. Okay. Here's ours. What is the point there? 3 by 2 comma 0. Now, if you see the distances now, there will be different distances here. The meaning of the problem I am explaining. Among all these, which is the smallest distance? The smallest distance is given to be root 5 by 2. For what value of A it happens? For what value of A it happens? Can you imagine? If this becomes 1, no? This becomes 0. A becomes 1. This becomes 0. Then it becomes root 5 by 2. So A is 1. So what is the point there? 1, 1. So this is the point 1, 1. I am elaborating the problem. I am elaborating the problem. So 1, 1 is the point on the curve which is at the least distance from 3 by 2 comma 0. That means the rest all the points are greater than this distance only. Rest all the points on the curve will be at the greater distance than this point. The shortest distance point is 1, 1 and the shortest distance is root 5 by 2. Root 5 by 2. Similarly, you have some more simple questions. Let me show you that. So here you said the answer is root 5 by 2. Okay. Next question. This is related to something, the properties of triangles. Let us see that this is little. The hexagon is to be constructed and then it is to be solved. We will see that in the next session. And let us see some simple questions. The orthocenter of the triangle formed by the lines xy equals 0, x plus y is equal to 1. Here, this is one more important concept which is to be understood, that in a right angle triangle, the vertex containing the right angle. In a right angle triangle, the vertex containing the right angle is nothing but the orthocenter, and the midpoint of the hypotenuse is the circumcenter. The property you must be knowing. In a right angle triangle, if it is a right angle triangle, xy is equal to 0, x plus y is equal to 1. I think you have noted the problem. I'll explain on the board. Let's see this. Now remember the question? The triangle is formed by 3 lines. xy is equal to 0. X plus y is equal to 1. We need the orthocenter of the triangle. and I discussed the equation of x-axis, y equal to 0. Equation of y-axis, x is equal to 0. This is given as a pair of lines, x, y equal to 0. You have to understand that. Third line is x plus y is equal to 1, which is like this. X plus y is equal to 1. We need the orthocenter of this triangle. Very simple. In a right angle triangle, the vertex containing the right angle is orthocenter, and the midpoint of the hypotenuse is a circumcenter. Okay? So what should be the answer for this question now? What should be the answer? Can you reply? Can you reply what should be the answer for this question? We need the orthocenter for this one. Do you reply, please? The answer for this question, the orthocenter of the triangle formed by the lines xy equal to 0, x plus y is equal to 1. Arun, waiting for your answer? Yes, you're right. You're right. That's good. It is C. So what is the learning here? In a right angle triangle, the vertex containing the right angle is nothing but the orthocenter, and the midpoint of the hypotenuse is the circumcenter. Okay. So for today, let us close the session. Some more questions are there. We'll be discussing, and you'll have the class by the same time tomorrow by 2:30 p.m. Okay. See you in the next class. Namaste.